Here we have the rules of logarithms. First of all, since a to the first power is a, that means that log base a of a is 1. Since a to the 0 power is 1, log base a of 1 is 0. Again, logarithms are exponents. Since they are exponents, we have this property here, which is the inverse property, as well as this one. If I keep the base the same, and I multiply, I add the exponents. If I divide, I subtract. If I raise to a power, I multiply, like bringing the x out in front. This one, which brings the negative out in front, is exactly related to this one, because 1 over n is n to the negative first. This final thing is the change of base formula, which is useful when you want to actually evaluate something with a strange base on a calculator, since you typically don't have any other base. So this thing is almost useless because you're always going to use a natural log or a common log of base 10. So this says to rewrite in either exponential or logarithmic form. Since the first problem is in logarithmic form, I'm just going to rewrite it using the definition. That means 7 to the negative second equals 1 over 49, which it does. And the second one, let's write it as a logarithm. So first is I'm going to say log, and the base is 9. The exponent, or sorry, the answer is 27, and the exponent is 3/2. Again, logarithms are exponents, so that's why it equals the exponent. Here you want to use the rules of logarithms to expand the expression. So I have a natural log of 2 divided by 27. Now the rules say that I can expand that by taking the natural log of 2 minus the natural log of 27, and there's nothing else I can do there. For the next one, there's a couple steps I can do. The first thing I might do is say, yes, I have the natural log of the square root of 3x minus 5 minus the natural log of 7. I've separated them so far. Now, there's nothing I can do with this natural log of 7. That's simplified enough. However, I can do more with the first one. So first I'm going to rewrite it as 3x minus 5 to the 1/2 power. Now, hopefully you now see why I did that. Because I can move the 1/2 out front because of the exponent. So I have 1/2 natural log of 3x minus 5 minus the natural log of 7. With these two examples, I want to condense the logarithmic expression into one single logarithm. So the first one is a basic example. I'm saying since I'm subtracting, that means I'm dividing them inside the logarithm. So I have the natural log of x divided by y. I'm going to follow the order of operations here. So first I'm going to say I have 1/3, and inside I'm going to say that's the log of x times x minus 4, since I'm adding. Now, and I'll do one more little algebraic thing here to make this look nicer. Call it the log of x squared minus 4x, just because it's a little easier to read. Now, I want to raise this all to the 1/3 power, everything in the logarithm. So I have x squared minus 4x to the 1/3. And one last step, I'll just rewrite that a little more explicitly. 1/3 power is the cube root of, so I have the cube root of x squared minus 4x. And that is the answer, log of the cube root of x squared minus 4x.